Hello and welcome to the final unit, Unit 4 of Microservices March 2023. My name is Jen. I will continue to be your host through the end of this. So let's jump right in. Our Unit 4 topic is Manage Microservices Chaos and Complexity with Observability. So it's all going to be about trying to figure out what's going on with your microservices based on the telemetry that you can get out of them. So before we jump in, a couple housekeeping items that are going to be familiar to people who've been with us for the previous weeks. First, if you're interested in obtaining the Microservices March badge, we are still offering that. The requirements are to attend all 4 of our webinars, either live like we are right now, or you can catch them on demand in the platform and complete the hands-on labs. I will say there is a little caveat. We had some issues with the Unit 3 lab. So the Unit 3 lab is no longer required to obtain the badge. It is a bonus lab. If you're still interested in getting some experience, go for it, but it's not required to get the badge. We are going to leave this platform open through the end of day on April 3rd, so that's Monday next week. At that point, we will close out the platform. This will no longer be available through On24, so you have until Monday next week to complete the badge requirements. After that, we'll be putting the webinars over on YouTube, and you can do labs on demand as well. But again, it won't contribute to the badge program. All right, second order of business. If you haven't joined our Slack community yet, this is the best way to ask questions about the content of the program. So I believe we have the link to join Slack in the resources in the webinar UI. So there's a little paperclip icon and you can click that and find the link to Slack. It's also available through the main On24 platform. And so join the Microservices March channel. Ask us questions, we can help you troubleshoot the lab. And then the other channels there can help you if you're interested in learning more about our open source projects. All right, moving back to this session, again, it's going to be a 3-part session. We'll have roughly 45 minutes of lecture, which is going to include a deep dive on some observability topics and a demo. We'll have time for a Q&A, which we ask that you please use the Q&A function, not the chat function. And we'll try to get to questions in the chat, but we may not see them. So please use Q&A. That way we can answer them for everybody. And then finally, if you've budgeted a full 2 hours to stay with us, we'll be here for the second hour of the program, available to do office hours for the hands-on lab. So if you budgeted time, again, you can do the lab right now during this session if you're here with us live. If not, you can do it anytime on demand through April 3rd. Okay, without further ado, let's introduce today's speakers. Javier, who is with us from Unit 1, is back. He's going to be our technical speaker doing our demo. And then our main speaker is Dave. Unfortunately, Dave is having some camera issues, so you don't get to see his lovely face moving on your screen. Perhaps Javier and I will pretend to be Dave for you, but he is here. So I'll go ahead and say, Dave, go ahead and excuse me, introduce yourself and share a bit about your experience with microservices.
Sure. So as mentioned, I'm Dave McAllister. I work on the NGINX side as their technical evangelist focused on open source. I've been involved in the observability space for about 5 years at this point in time. Like I started with microservices before that, working in middleware messaging, particularly with things like AMQP, and then some of the other pieces that we're building out for projects like the Singapore Smart City and the FAA SWIM project. So I am definitely an open source geek. I'm a standards wonk. And honestly, I'm looking forward to talking about one of my favorite topics here, OTel and observability. Javier?
And I'm Javier, if you remember me from the first unit. Thank you for coming back again. I come from an engineering background, and I've been working in microservices environments for probably the last 8 years or so. And my experience has been mostly we use metrics a lot in our work with microservices, and OpenTelemetry was definitely around when we were deciding on monitoring choices for our services. And I have a little bit of experience with traces, which we'll dig deeper into today. But yeah, I'm also excited here to be taking a complex topic and hoping to make it a little bit more understandable for everyone.
Cool. So our topic today is going to be observability. And honestly, when we start talking about observability, hot topic in the marketplace here, what's driving this move to observability? And very honestly, it is microservices. It's the complex nature. It's that they are multiple languages, that they're independently deployable, and they're actually not always owned by a single team. And when this comes into play, we have lots of communication issues, lots of small services that do as much as necessary, but not as small as possible inside of that. And so when we look at this, we have microservices driving this move to observability. Observability lets us see things that we may not know could go wrong, what's known as the unknown unknowns. And when we get into the microservices space, we start getting into this complicated and chaotic behavior. When we had a large mainframe running a monolith, it was pretty easy to go look and see if the lights were flashing on the machine. We can't do that anymore. In microservices environments, we've got a complicated environment. We've got constraints. We've got this loose communication but tightly coupled environment. Likewise, when we move into clouds, we have a chaotic environment. We have elastic and ephemeral behaviors. We don't know where things are running. And so, being in the math space here, you only change one variable at a time. Well, microservices, along with the move to cloud, made us into basically a multivariable calculus. And observability actually lets us start looking at what is going on as well as what is possibly going wrong. So there are usually three things that we look at here. We look at metrics. Do I have a problem? It's your alert structure, and it's usually what's driving your dashboards. You have traces. Where is the problem? And this is the new member of our observability and monitoring space, being able to pinpoint in what service or between what services the problem can occur. And then finally, logs, the ultimate source of truth. What does the application or the infrastructure think is going on at the same point in time? So detect, troubleshoot, and root cause. By putting these together, monitoring lets us look at things that we know can go wrong. Observability lets us find things that we didn't expect and explain why it happened to move it into that known category for this. Basically, it's driving to reduce the mean time to clue, how long it takes you to find what's going wrong, as well as, because of the mean time to clue, can reduce your mean time to resolution. And those things are something that's really important in our new complex environments. So when we start looking at observability, we do have some traits that we really would like to make sure that come into play here. We want to avoid lock-in. Data should not lock you into a single solution. And that's something that we'll touch on in the observability, on the OpenTelemetry space. We also want to make it as easy as possible for implementation. And Javier will get into a little bit more of the how we do this. This is not necessarily what we really want at this point in time, but things like automated instrumentation make things a lot simpler for us. And then finally, we want the ability to use whatever visualization we want, because data is not very useful unless we can actually analyze, aggregate, and visualize it. And then finally, because we are in an operating environment, usually in a production environment, we want the piece that's doing this observability aspect to have as little resource use as possible. We don't want to burn 5% of a CPU just to be able to collect data. We want it to be as low as possible, as well as being able to look at what's coming next. So today, OpenTelemetry is heavily driven by, observability is heavily driven by OpenTelemetry. And OpenTelemetry itself was the combination of two open source projects, OpenTracing and OpenCensus, Those two projects got together in March of 2019 and decided that they were trying to solve the same problems. They were close, but not quite to the same way. And so they merged into OpenTelemetry, which is under the Cloud Native Computing Foundation activity space. It is the second most active project in all of CNCF, only exceeded by Kubernetes at this point in time. Those pieces were really nice because we already had a background in what was going on and how to make it work. Open Tracing had been delivering tracing functionality for quite some time. Open Census grew out of Google's original Dapper work, moved into Census, and then became an Open Census project. Those things gave us the ability to support existing projects as well as supporting any code at any time. So we came into the OpenTelemetry space with a pretty stable, robust, production-ready system. Since 2019, it's been expanded. It's been more stable, and it's grown to be the choice in delivering observability signals across the entire monitoring industry. I cannot come up with a single vendor that doesn't have OTel support at this point in time. So OpenTelemetry is focused on the data, how to get the data from your application. It lets people build and collect their own collection strategies. What do you want to collect? Where are you collecting it from? And where are you delivering it to without having to go through a vendor lock-in phase for this? And then OpenTelemetry puts the focus there on analytics, not on collection. This is why there's so much popularity inside of this OpenTelemetry space, both from a vendor viewpoint, because writing for an agent to collect data, unless it's very unique, is not necessarily a win for the people who spend a lot of time doing aggregation, analysis, and visualization. So OpenTelemetry immediately removes that data barrier. The data can be brought in from any source and be delivered to any source. And therefore, we can spend more time in figuring out what the data is telling us. And so, great, I've got all this data. Well, what's it good for? Well, observability generally tracks requests. It can also track infrastructure. It can track other things. But when we get into tracing in particular, we're actually looking at an individual request crossing from start to finish. And that gives us insights into what the application is experiencing, as well as what the user is experiencing. And so what you're looking at on the screen here is what's called a red dashboard, rate, error, duration. And during this, I can see that over a 10-second period, which is the metric I chose for display here, that I'm running about somewhere between 14 to 20 requests per second. My normal request latency is running about 250 to 200 milliseconds here, but my error rate every now and then pops up, and I'm beginning to see that I've got some errors that are creeping into it. So this is an aggregated viewpoint. I'm showing a 10-second viewpoint. Over on the right, I'm showing a strip chart of the same data coming in that's more of a point-specific basis. So what OTel did was allowed us to start looking at the individual user request, not just the infrastructure underlying. And that gives us that mean time to clue and mean time to resolution aspect very quickly. So we can quickly find out what the user thinks is going on, because as we all know, users only care about their request, whether it was successful, and how long it took. OTel gives us that information very quickly, very cleanly, and lets us figure out what the underlying issues may be. So while that's one, the red monitoring aspect, this is a case where the observability signals can drive a lot of different models here. So we can drive RUM, real user monitoring, and actually track the behavior of a user from start to finish. We can look at what's happening in terms of geographical dispersion. Synthetics, which is where we set up sort of the artificial single user case. Synthetics lets us go in and pull that data and use it for testing and error analysis, so we can actually see what impact a change may have on us before we roll it to production. Network performance monitoring. What's the underlying network? We're tightly tied together, but loosely coupled. APM, application performance monitoring. What's the application, the backend for our web looking like? And then, because nothing ever runs by itself, being able to look at the infrastructure itself and find out what's going on with our machines, our networks, our disk. All those things are important. The visualization between that can vary in lots of different ways. It can be looked at a workflow basis. It can be looked at an infrastructure basis. It can be looked at a Kubernetes first basis. And so things like having a noisy neighbor problem are not solvable by any single functionality, but the combination of an APM approach and the infrastructure approach lets us quickly narrow into having somebody that's eating all the memory inside of this noisy neighbor space. So let's take a look at a trace. And there are multiple ways of showing traces. This is what's called a directed acyclic graph. And it shows coming in the various pieces. We can see what the service is and how long a service may take. We can see the connection points, where my requests flowed in my microservices. And we can show how long that connection took. And as you continue going out, you can start seeing each of the pieces involved and where it goes into it. And so we've got request path, we've got connection duration, we've got the services that are being touched inside of here, as well as the service app duration. And then we can bring that back up and start looking at this as rate error and duration functionalities, as well as start diving directly into trace. This is an analysis site. It changes based on what your analysis tool looks like. But it lets us very quickly look at what a complex trace looks like, as well as how it flows through our services. The other common way of looking at a trace is what's called a waterfall plot. And this is showing us the same basic information, but a different approach. This is showing us my request path moving from the top, the trace itself, through the various elements, the spans. And again, it's showing me how long each piece took, as well as the duration for each services. The colors may or may not be important. It depends on, again, your application tool. But it can also start breaking down and saying, okay, the application took this much time, the service, the network took this much time, a database call took this much time. So you can start narrowing things down quickly from simply looking at a single trace. And then inside of that trace is something you can call baggage or resources. We'll get a touch of this a little bit more. It tells us where things are running, what things are running, and how we can make use of those pieces. So the architecture is very simple. There's an API structure. The API is how we put traces together and make them work. There's a next section, the SDK piece, which is actually the piece that does the real work. It's what actually pulls the stuff out. And then finally, the collector, how we pull all this together to aggregate and send it to some place that we want. Each of these things are standard, but each of these things are also extensible. And so it becomes really easy to build a observability structure specific for your particular case, while staying within the ability to have that data flexibility and movement. So API packages, these are when you call them. Tracer. A tracer is responsible for setting up what's going on and tracking the current span. A meter is how we collect the statistics, the metrics access. And then this baggage manager, it propagates unique key pair values, key value pairs across the system, so that as we move from service to service, we keep a continuity structure going across each of those pieces. Each of those pieces is in a different state. So right now, tracing and metrics are both in the stable state. And so the specification is stabilized. Baggage is stable and feature froze. So we're not going to be adding a lot of new stuff to what we're tracking underneath of our traces and metrics. The SDKs are language specific, and the tracing SDK is pretty stable. Metrics varies by language for each of those pieces. Baggage is very definitely stable. Protocol, which is how we want to interface to these things, the first two are stable. Logs are still pretty much draft. And the API for logs is actually currently not under development until we finish the SDK. The protocol is stable. The spec is reasonably stable. But right now, we focus a lot on tracing and metrics, and logs are useful, but they're not part of the spec at this point. And as you can see, it varies by language. If you're in JavaScript, C++, they're pretty stable in the first two, and then you can see that logging can vary across it. So touching on tracing, I've mentioned a few of these things. A span is the unit of work. A unit of work can be a single service or inside of the service itself. A trace is all the spans together, and it can be thought of, again, it's at a cyclic graph where the spans are defined across by connections, or as a waterfall plot where they're defined by order of call. And then inside of that, we have all this other baggage that we carry across. When we are doing this enabling distributed tracing, and we'll get more into this with Javier, we're looking at traffic inspection. In other words, you can look at a service mesh and look at the content propagation or the endpoint connections without necessarily having to look inside of the application. And then we can also look at this code instrumentation, instrument the code specifically to get unique information. When we look at code, we add a client library, we instrument the specific services, we add things to the spans that we'd like to add to it. For instance, attaching logs that are being written out at the same time the span is being called, and then what other pieces we want. You don't have to do all of this. You need to look at what pieces make sense for you. There is one important thing to consider, and this is something called semantic conventions. There are certain things that we have defined as part of the OTel specifications that you will get as part of those resources, that baggage that's coming into place. So there are certain things that are automatically going to describe what's happening. If you are in an HTTP situation, your baggage will include the various HTTP semantic conventions, where it came from, what the call looked like, what the client access looks like. Likewise for general databases. And you can extend this because there are semantic conventions that allow you to extend services. And so, for instance, with function as a service, AWS Lambda, Fargate, those actually have that capability right now to have a semantic convention for those specific cloud environments. So, metrics, the other side that we're really interested in. It's broken down into gauges, which look at instant point in times. And that's what we use to build these line graphs, for instance. Cumulative counters, and this lets us build that aggregation structure. And then histograms, how we group things together. And so those give us the ability to look at rate functionalities, and rates are defined inside of here. So how we can see how things are changing. And metric concepts are fairly common, and again, are extensible to specific functionalities. Metrics also have their underlying semantic conventions for that. And so you can see very quickly the basis ones. This is a short list of these, and you can see what their aggregations look like. You can sum things, you can look at min maxes, but each of these pieces allow us to do different things, be it observe, so a monitoring category, be it record to save off things, or be it to add things together to keep a running total. And then logs are early days. They're beta-ish at best. The log specification is pretty stable. I feel pretty comfortable with the log specification. It's designed to map between existing log formats because we can have multiple kinds of log formats. We already have infrastructure logs. We have a very common practice for system logs, syslog. But we also have third-party applications, your favorite database functionality, as well as the applications you write, have them what are called first-party applications. Logging needs to support all of these. And the mission for the logging is to be able to bring logs in and reduce logs back to their original format, no matter whether they came in as an infrastructure or third-party log, using OTel as a transport mechanism and as a stabilization for commonality. And so top-level fields, key value fields. And as some of these you can see, they're related to standards, W3C trace flag, and then you can add, again, more functionality and make it your own thing by adding attributes around what the log is being written. And the heart of this is this collector. You can think of this as an agent. It has receivers. It can bring in data from any source that's common. If you've got one that's not, you can write your own receiver. It can then process the data in the middle. So you can actually do things to do redaction and remove information or do different aggregation structures. And then you can export it to wherever you want to go. The OTel collector is the heart of the system. And if you spend any time looking at anything, get really familiar with the OTel collector. So, quick ways of getting started before we get into the actual how here. Your apps do need to be instrumented so that it emits your desired observability signals. So you may not want traces, you may not necessarily want metrics, and you may not necessarily want logs, but you need something. And so generally speaking, we see people quickly instrument for metrics, start instrument for tracing, and as logs become more available, move their logging structures into observability through OTel. You can use automatic instrumentation. Your mileage will vary on how your results look like here. You can manually instrument your code, and nicely, you can use both automatic and manual at the same time. And so what this basically means, just add the appropriate files. For automatic, it's language independent. For manual, you need to do some importing, create your traces and metrics yourself, and then export the data. On the tracing side, you instantiate a tracer, you configure things. Metrics, you instantiate a meter, you configure things, and you're pretty much done. A lot easier to say in words than necessarily writing code, but nonetheless, it's a very clean and clever structure for this. And then finally, before we move to the demo, I want to sum up with a common quote from mine. Brian Kernighan wrote in Unix for Beginners in 1979. The most common, the most effective debugging tool is still careful thought, coupled with judiciously placed print statements. Observability is our new print statement. It gives us insights into what our applications are doing at the moment. So we don't necessarily have to purely infer from outside appearances. The applications are now telling us what's going on, telling us how it's interacting to the infrastructure, and telling us where we can look to make things both fixed as well as better. And with that, let me turn this over to Javier to look at a quick demo.
All right, thanks, Dave. And I think we'll be seeing, it's great because a lot of the stuff that you just mentioned, we're going to be seeing right now as we move into the demo. But I'm going to kind of roll through a lot of the code and stuff like that a little quickly because I really want to get to a point where we're looking at traces. We're going to be focusing on tracing today so that we can look at traces with Dave. But I'm going to talk about a process for instrumenting because, as Dave alluded to, you want to go into this with a strategy. And the process that I'm going to kind of suggest that we follow is that we take some time to understand our system. We're going to take some time to understand the business process that we are going to be instrumenting. We're going to set some goals for like what we want to get out of that instrumentation, what we want out of the traces. Then we'll set it up, write the code in a very simple way. We're not going to worry too much about what we're sending and that type of thing. Then we'll go through and we'll analyze what we're getting and see if it meets our goals, and then we'll adjust based on that. So if you joined us for Unit 1, I just want to take a moment to go to the first step in that process, which is going to be understanding what we have. And so I'm just going to talk about the components here, and then I'll move into what the business process we're going to look at is. So here we've got NGINX acting as a reverse proxy and load balancer in front of the system. We've also got two microservices, both written in Node.js. This is the Messenger service, which is kind of a chat application. You can think about it like LinkedIn messaging or Facebook Messenger. We've also got another microservice called Notifier, and its responsibility is to let people know, generally notify about things in the system if there's other stuff going on, but generally let people know when they've received a new message. In the middle, we've got RabbitMQ, which is acting as an event broker. So we'll see how that comes into play in the flow. And then we've got Jaeger, which is a combination of some of the stuff that Dave was talking about. So it's a combination of an OpenTelemetry collector and also a visualization and aggregation tool. Now, let's understand we'll choose one aspect of how the system could be used and understand it and then instrument it. So here, I'm going to model what happens when one user sends a message to another. So if you look at step one, this is going to be, say, Dave is sending me a message. So he sends that message. He performs an HTTP request, probably through a UI, that goes through NGINX and gets routed to Messenger. Messenger then validates the message and writes it to the database. This is a Postgres database. At that point, Messenger dispatches an event on an event queue. And there's no target for this event, but it just gets pushed out there and RabbitMQ accepts it. And then at the same time, it'll give a response back to Dave saying, we sent your message correctly. Also, Notifier will be listening on that queue, and probably around the same time that this message got dispatched, it's going to pick it up and it's going to look at it and say, okay, who's this message to? And it'll go into its database and it'll look at what I've told it are my notification preferences. So maybe I want an SMS message, a text message when someone sends me a message to let me know to go check. Or maybe I want an email or a push notification. And then it'll send out the notification. So that's kind of the flow. And so based on that, we're gonna make some technical goals as well as some product level goals. And I'm kind of force these on you, but you would think about these in terms of your own system. But the first one is just very simple, like basic, can we understand it? So you're not gonna have a diagram like this for every business process in your system, right? So we're gonna say, I wanna be able to look at the traces and I wanna be able to understand all the steps that a request goes through during this business process, during the new message flow. The second goal, is that I wanna have confidence that the flow is executing from end to end within 5 seconds under normal conditions. So this would be an example of what some people might call a service level objective, or basically a promise that we make to the users of our system that it's going to work in a certain way. It's going to maintain a certain level of responsiveness. So here, we're just going to say, when I send a message, the other user should get notified by it within 5 seconds. 5 seconds may seem really slow, but this is kind of the maximum that we want to accept before we consider the system to be down or degraded. And third, I want to see how long, and this is a little bit more complex, I want to see how long it takes the notifier service to begin processing the event dispatched by the messenger service. So this is more of a technical goal. And if we go back and look at the diagram, we're going to see that the message is dispatched by messenger onto a queue, and then the notifier picks it up. But there might be like 800 messages waiting here, and notifier that were about previous messages that were sent. So notifier might be taking a long time to chew through all those messages and process them. So we want to know if notifier is having a problem handling the volume of messages so that we know that we need to maybe horizontally scale notifier. So with that being said, let's jump into the code. And what I'm going to do, I'm not going to write all the code for you because, like I said, I want to get to the traces with Dave. But this is going to be an example of a lot of the concepts that Dave introduced. I'm going to skip over a lot of this stuff. You'll see a lot of familiar names. You'll see the SDK. And then in this case, we're using the JavaScript one, which is one of the more mature SDKs. You'll see semantic conventions. He was talking about those. We'll see a library related to the format with which we export the trace. So let's just go through the code here and understand it. And one thing I want to point out before we go into the code is that this file, it sits, so here's the main application file. This file, I've just called tracing, and it sits right next to the application, but not in it. This code is not part of your business logic. It just sits to the side, and it's all telemetry, OpenTelemetry related code. So the first thing we do is we create a resource, and this is basically going to be our definition for the thing that we're tracing. And then we're using some of those semantic conventions to say, okay, we're going to send what OpenTelemetry considers the service name, and we're going to call it messenger. So this block just kind of instantiates an object that is going to represent kind of the service that is producing the traces. Then we simply instantiate the SDK. So if you're not a JavaScript person, new is going to instantiate, make a new instance of this Node SDK. We're going to pass it the resource that we just made to let it know that this is the service we're talking about. We're going to pass it this object that we pulled in from this library that tells it to export in OpenTelemetry format. You can export in straight to the console for testing, and you'll do that in the lab. And then you'll tell it what instrumentations you want. And for this one, we're going to use the Node auto instrumentations, which are very, they cover a lot of stuff, and they'll give you a lot of stuff automatically. So this is the only piece of like, here's what the instrument I'm going to give it. And you'll see what that produces in a moment. And then we'll start the SDK. And so that's all we need for the JavaScript side. So I've got almost identical code in the source code for the notifier application here, it's exactly the same except it says notifier there. So we're just identifying the different services. So that's the two, so that we've now instrumented messenger and notifier in a very basic way using the OpenTelemetry auto instrumentation. Now let's take a look at NGINX, which is a bit different because those are the three elements that we're going to instrument. So with NGINX, I'm going to be using the NGINX Docker file. And what I'm going to be doing is adding the OpenTelemetry C module that gets added to NGINX to enable OpenTelemetry to be sent. So with NGINX, you have third-party modules that can be compiled and added to NGINX. So that's what this code, I'm not going to go over this in detail. There's a blog post that kind of goes with this that'll have this code for you to look at in more detail. But essentially, we'll do the compilation of this OpenTelemetry library. We're downloading it and compiling it. And then we're going to load it up in NGINX in the base config file. The base config file for NGINX is going to look really simple. It's a very simple reverse proxy setup where we've defined an upstream and we've named it messenger. And then we're telling NGINX to listen on port 8085. And then any request that comes into messenger is just, that comes into the NGINX reverse proxy is just going to get forwarded as is to messenger. So that's kind of all we have. And what I'll do is I'll show you, I'm going to build that Docker image right now. So to kind of show you that it's not, once you've got all that set up, it's just a simple Docker build command. And then we're going to run it. And you'll see in the logs, you'll see a lot of error, but this is just because it's coming out of the NGINX error log. The error log is where a lot of informational stuff also comes up. So it'll tell us that it's starting up some of the OpenTelemetry based systems. So now that we've got everything up and running, I want to just take us through that business process. So I'm going to send a post that creates a conversation between two users. And we'll see that it created the conversation here. And then I'm going to send a post request that will just send a message from one user to another. So it gave me the message that wound up getting sent. And just for fun, let's reply so that we can have a whole conversation. It's a very interesting conversation. And we'll see here, if I go into the logs for the notifier service, that it's telling us it's sending notifications. So you will see this is an example of it pulling a message off the RabbitMQ queue. So that's what the message that the messenger service dispatch looks like. And then it's saying, okay, I'm sending an email message and I'm sending a text message. So that's what it looks like. And since we've done the auto instrumentation, we can now jump into the Jaeger UI. And we have all our services that popped up here because we named them using the semantic conventions. And we can click Find Traces, and we can see, let's look at this one here. We can see that we've got a list of traces. And Dave, this is where I'd love you to jump in, but I'm going to talk about our goals. But let's look, this is that waterfall view of the request. You can see this is where I sent that request. This is that message send. And we can see that messenger, the NGINX, messenger LB is what I've called the NGINX service. So this is NGINX. We can see that messenger service is represented here, and we can see that the notifier service is represented here. So going and looking at our goals, the first goal was just that we want to understand all the steps the request goes through in the new message flow. And what I do for that is I take a look at the top. So I just want to see all the names, basically, and all of the events that we're really caring about. So here I see at the top, I see that if I expand this down, I can see that it was a post request. I can see that it came back with a 201 status code, which means it created the thing I asked it to create. And the target was what I expect. If I pull down information about the process, and you notice I didn't tell it to do any of this. This is all that semantic convention coming in. You can see that web engine name is NGINX. So this helps me verify that indeed the first thing that happened was that NGINX handled the request. So if we jump now down to the messenger portion, and I'll jump back to the kind of the guide. So we've confirmed this. Now we want to see messenger. So here's messenger. We can see that it came in, and we can see similar information. Post request, again, the semantic conventions. Status code 201. The target is what we want. So we can see that happened. We can also see that we see these, since we're using Postgres, these PG pool connect statements, I'd like more detail in this. So this is where I might, after I'm done with auto instrumentation, might make some more changes. But this tells me that it hit the database. So that's, this connection here. And then I see this chat queue send, and I can look at the tags again, and I can see that, okay, messaging system is RabbitMQ. So this was a producer span, so it produced the event. So this represents the step 3 here, sending the message. Whoop. And then on the notifier side, so we've confirmed that notifier was involved, and I see chat queue process, and I can go down here and say, okay, messaging system is RabbitMQ, and the span kind is consumer. So I can see that it consumed it. So that takes us to here, step 4B. And finally, I can see some more database connection stuff. And again, this is a little, I would probably want more data on this, but I can see that it's making that connection. Now, that's the end of the notifier spans. And what I don't see is I don't see step 6. So looking at what the auto instrumentation gives us, I cannot say with certainty that I understand all the steps just by looking at the traces. So that's something we're going to need to work on. The second goal is that I want to have confidence that the flow is executing end to end within 5 seconds. So because we don't know, because we're missing step 6, this is also not something that we can answer with confidence, because I don't know, maybe step 6 is taking 10 minutes, right? But what we can see is we can see that the whole request from beginning to end, if we go back up to the very top and read that first span, we can see that the whole thing took about 221 seconds. By the way, I'm running this on a laptop that I got in 2014. So that's kind of the reason for the slowness here. But this took 221 seconds. And so that tells us that we're definitely far away from 5 minutes. I'm sorry, 221 milliseconds. We're definitely very far away from 5 minutes, but we can't answer it with confidence because we don't have that step 6. So that's one we'll have to work on as well. Moving to the third one, we want to see how long it takes the notifier service to begin processing an event dispatched by the messenger service. So that's, again, we want to see how long, what the time difference is between step 3 here happening, this message going out on the message queue, and step 4 happening, this notifier application receiving the message, beginning to process it. Not processing it to completion, but beginning to process it. And so for that, we can move down, and let me close up some of these spans that are not relevant to us. And we can just look at the spans that were sent from RabbitMQ, or rather the library that interacts with RabbitMQ. And we can see here that on the messenger side, we have a span indicating that the event was dispatched 27 milliseconds after the beginning of the request. And then we see a span on the notifier side that shows that it began processing the event 49 milliseconds after the request was sent. So that tells us that definitely that is not taking a really long period of time. So we can actually check off this one. We can say, all right, we have enough information to know that that's the case. But we have these other 2 goals that weren't met. So this is an instance where you can see that we get a lot from the auto instrumentation. We get all these spans, and they have a lot of information that could be useful to us. But in terms of our particular goals, they're not helping us get there. And I see that we're kind of running short on time, so I'm going to not be as detailed on the code as I would like to be here. But this is going to be an example of doing a manual, sorry, just a moment. This will be an example of doing a manual trace. So I need to add things manually to the business logic of the code. So I'm going to go into the code for the notifier application where the notifications get sent. I'm going to import, and I already had this imported from including the libraries and the tracing file, but this is now my main application code. So I'm going to import this library, and then I plan to walk you through this code, and I still will a little bit, but I'm going to do it way faster. So then I'm going to find where the notifications are sent. And here we're just logging it out to the console. So we're looking at all the ways that the user asked to be notified, and we're going to just dispatch a console print for those. And I'm going to add a bunch of code here, which I will explain to you. So Dave talked about tracer providers. So we're just pulling a tracer, and that's going to allow us to produce traces. And then it's simply a matter of, if we break it down, it's just, we call start active span. We give the span a name. So this is going to be the span that will indicate that we started to try to send notifications. We can provide metadata, random metadata, whatever we want. So in this case, I'm saying, let's record the user that sent the message. And then we get a handler. And this is where we put everything that we want to measure in that span. But instead of measuring something immediately, I'm jumping into that loop of notifications, and I'm starting another span, a child span. So we have a parent span and a child span here. And I'm giving that child span the name notification send. So what we should see is one notification send all span, followed by, between 0 and 100 notification send spans. And again, I'm providing some metadata. That's whatever you want. And then here is where I perform the actual, thing that I'm going to measure. In this case, it's a simple console log, printing to the log. And then I just got to make sure I end my span. So I'm sorry I couldn't spend more time on that, but it is what it is. And then I'm going to restart that application. And then we'll send another request, and we'll see if we can solve those problems that we had before. So I'll go over here, and I'm waiting for a moment, because the other thing that I would do is turn off some of the file system auto instrumentation that Node.js auto instrumentation provides us. It produces about 1,000 file system access spans for Node.js starting up, and so I don't want to wait for those to kind of roll through. So that would be absolutely something we'd pull out. I'm just not doing it for the interest of time in this demo. Okay, so let's send this another message. So we see we sent a message, and we should be able to go to the Jaeger UI and see it. There it is. So this was just sent just now. And let's go down. So all the other stuff is the same. So we've got Messenger LB, Messenger. We see the chat queue send here. We see the chat queue process here. And now if we look at Messenger, look, we see it's a little small. So I'm going to, oh no, that doesn't help. We see a notification.send all happening. And we see it happen 261 milliseconds after the request started. And then nested underneath that, we see two notification.send spans, one of which says notification type email. That's the custom data I put in there. And then the other is notification type SMS. That's another custom data. And you can see that now everything's included in the span up until step 6. So we've got everything there. And the entire duration of the request is 224 milliseconds. So going back to our questions, do we understand all the steps that the request goes through in the flow? Now we do. We've gotten all the way to step 6. Second question, do we have confidence that the flow is executing end-to-end within 5 seconds? Yeah, we know that this particular request happened in less than a third of a second. So we're safe on those. So that's an example of kind of using goal-driven. So if we hadn't set these goals up front and just auto-instrumented and released our application and then said, okay, we're doing tracing, if we had a major incident where stuff was backed up, one, we wouldn't know all the steps. Say I have a new person working on the service. They wouldn't know all the steps just by looking at the trace and be able to make quick judgments based on that. And they also would not have been able to tell if this thing was taking longer. We wouldn't have that data in our system. So it's important to set goals up front. This is just the tip of the iceberg. This is the very beginning. You do a lot more tuning of your traces moving forward, but that's a basic example, and you'll get into it in a little bit more detail in the lab. So that's me.
If I can add just a quick color commentary on this, what you just saw was the completion, something that actually was successful. If you had had a failure, you would have been able to see which microservice had failed to complete its task as well. And that, again, is really an important aspect of when things go wrong. The other thing is that this also gives you a solid baseline for changes. Microservices change individually. They don't usually change as an overall gestalt. You don't change, every microservice at the same time. And so now you have an understanding of what proper performance looks like, and you can quickly see what the changes impacted your system. And so those are two other aspects where observability is heavily used, not just in production, but also in the testing and quality assurance aspects. And just because the 5-second rule here, it's a well-known survey that's been done for years that for an individual user, 3.7 seconds is the hate point for your web application. If it goes past 3.7 seconds, you have, I think the last survey shows you have an 89% aspect of the person dropping it or trying to requeue it. And so 5 seconds is actually a very, very solid target for that activity.
Yeah, and I think another thing in which maybe we can get into in the Q&A, because I see a question related to it. But one thing to note is that we didn't do any complicated configuration, but we still got a distributed trace. And one of the reasons I included the RabbitMQ event bus in the demo is to show how the auto instrumentation. I was actually surprised by this because I'd never done this in JavaScript before. That I didn't have to do anything, and I got a trace all the way through an asynchronous process. Like we think about HTTP requests, you send a request, you get a response. That type of stuff is really easy to track, make sure that you get all the data back, and it's in one package. But when you've got an asynchronous process in the middle, which Messenger sends it, and it doesn't wait for a response, it just sends it off, and something else picks it up. To be able to get a distributed trace with 10 lines of code in each service is pretty powerful.
So I think we do have a question, right?
Yeah, I think we've got one in the Q&A. I'll go ahead and toss it up on the screen so that everyone can see it. Sorry, the UI is a little finicky. Come on.
And Jen, after we show this question, I can actually show the asker an example of this.
Yeah, it'd be great. So the question is, are there tools available to visualize the architecture for the deployment of a microservices heavy app? By architecture, I'm thinking of a graph or schematic, which shows the physical assets, the services they are running, and the interconnections between them. So short answer, yes, right?
The short answer is yes. Yeah, the short answer is yes. And most of the time, visualization is very dependent on the service that's doing the visualization. But again, if you look at that directed acyclic graph, we didn't click into the example I showed here. But if you clicked on the service itself, it will show you the instance or instances that are running, what their physical structure looks like. And you can actually usually go from that functionality to looking at what the infrastructure is telling you about that specific physical structure. In a Kubernetes environment, it's going to look at the nodes and the pods, and it's going to literally give you that information specific to that specific instance running at that specific infrastructure. So that model varies heavily across whatever one you want to. And I'll turn it back over and let you show it, Javier.
Yeah, so I'm just going to reinforce what Dave said here is that here you're seeing, so this is using Jaeger, and I didn't configure this. I just clicked a different tab, and you can see that DAG stands for directed acyclic graph. So here's what we got auto-generated by the Jaeger visualizer based on what we have. So we can already see, even though I didn't set anything up, I can see kind of the arrows pointing between my services. It's not the level of detail that the question that Ron was asking about, but this is what you get for free. And there's other sort of like ways that you can visualize this force graph here. You can kind of see how things connect. But there are other more advanced visualization tools. I think Dave could probably tell you some of his favorites that might give you, if you provided extra metadata, would be able to give you a much more comprehensive picture.
Yeah. So and I've worked with a number of them, but almost all of the ones who have focused on the tracing space and in the commercial space have the ability to do that direct connection to the underlying infrastructure. When we run through a modern microservices model for this, What we quite often do is take a known trace, not quite a RUM, real user monitoring, but one that where we've started it, we trace it through, and then we look at the underlying infrastructure. Kubernetes is really cool and really powerful, but the thing is you don't really get to direct where it goes. And as it expands and adds elastic behavior to it, you also don't necessarily know where it shows up. In a tracing environment, because we are looking at each individual request, we can actually see those changes happen on the screen to whatever the display looks like. The ones that I'm most familiar with, Sumo Logic, Splunk, Lightstep. I just spent a little bit of time clicking on one near and dear to Javier's heart, Datadog, last week. Dynatrace, they all have this ability to not only show you the trace, but also show you the underlying infrastructure that the trace was executed through. So it's a really quick and easy way of seeing the combination between infrastructure, the combination between application and its request with a nice visual approach.
Okay, I think that is the only Q&A for now. And so what we'll do is we'll pivot to the second half of our format, where we'll be doing live office hours for anybody who wants to stay online and complete the Unit 4 lab here while we have some technical experts to troubleshoot or for Q&A. And so the way this will work, again, if you're new, we have one more question. We'll go ahead and grab that question while we can. So we have, is there a limit on how many service calls can be added and visualized with Jaeger? For example, Spring Batch having 200,000 records performing database writes.
And the answer is yes, there is a limit. Part of the thing around tracing is that a trace doesn't actually exist until it completes. And so you can't see a trace past a certain point. The ones that I'm not familiar with Jaeger, but the ones that I'm most familiar with usually limit you to a maximum of 1,000 spans. Inside of the OpenTelemetry spec, I can't pull it off the top of my head. There's a lot more capability there, but the problem is that after a while things start timing out. Most of the common things will terminate a trace if it goes past that 2-minute mark. It will just say trace never ended, because it can't produce metrics and it cannot produce the request pathway until it knows that it's done. So 200,000 records is a lot of records to try to go into a single trace.
Yeah, and this is an example of where choosing the insights you want up front, and then perhaps using other ways to visualize those very large operations might be helpful, right? So if you set goals, and maybe you have like a certain query that you're really nervous about, you might instrument that query manually and have an alert on it. If you've got 199,000 other queries that are going on, you might be wanting to have metrics that are looking at average query time, giving you the P99 on your query times, and combine that with referencing something like your slow query log and having metrics set up to track that. And so when you've got something that big and you're instrumenting it, focusing on like what's the basic stuff that you need to know, the broads, like we talked about, what are the steps of this and are they all happening? And then drilling down to specific insights that you want and instrumenting for those instead of sort of dumping everything in. And you could do a manual trace that is like, okay, generally is the database interaction in this critical part that I expect to be a bottleneck happening within tolerances. So it would just be a time when you need to sit down and think about what you want to know and be smart about how you're writing your
And keep in mind, this is actually one of the strengths of OpenTelemetry. You can choose what you want to receive. You don't have to receive traces, metrics, and logs. You can only receive metrics on certain portions, traces on certain portions, and continue to integrate your logs as wanted. What Javier just described as being able to track metrics around those pieces, I can still keep a similar ID. I'll have an ID that's associated with it. I can write that into my log file and actually do a direct correlation between those two. So it's really easy to just do the step between these things, as well as pick what you need to have in each of those pieces.
And I know we're bumping around beyond the time, but Dave, I have a quick question I think is important that I don't know the answer to, which is what does OpenTelemetry provide in terms of options for sampling? Because when you're dealing with really large amounts of data coming in, sampling is often something we want to do. But yeah, I'm curious about that.
So sampling can be broken down into a category of head-based or tail-based. So head-based sampling is purely random, and it's built into the collector environment that basically say, I want you to collect 10% of the traces and save them. It will collect all of the metrics, but not necessarily all the traces. The other side is tail-based sampling, which is actually a model of filtering, which says, I'm going to look at the trace once it concludes and see if there was anything that flagged that makes this unique. So good traces will not go through, but if you have an error show up or if you have a time that's structured, these are built into OpenTelemetry. There are other things that can be made use of this. Something I like to call post-predictive, which is keep everything for a certain period of time and then get rid of things if you don't have a problem occur. That one's not in the OpenTelemetry model, but it's the one that's probably the safest for debugging and troubleshooting purposes. So we did think about this. There's one former client before I came to work at NGINX who wrote out 43 terabytes of log files every hour. When they added tracing to this, that number went up to over 90 terabytes per hour. They can't afford to keep that. And even if you got that much, how the heck do you search it and understand it? And so we looked at how we could deal with sampling in different ways. So yes, OTel, we thought about the data issue.
All right, so if more Q&A comes in, we'll either answer it through the Q&A widget and just reply all so you can see answers, or if we think that it's worth interrupting, we'll come on screen. But this is the time to transition to doing the hands-on lab. A reminder, if you're going to do the lab, you do need to go from start to finish. If you pause the lab, that eats into the number of attempts that you get. So make sure if you're prepared to do it, you're prepared to go all the way through in one sitting. So you have 3 attempts to complete the lab. That way, if you do need to step away or you want to try it more than once, you can do that. It should take roughly 30 to 40 minutes for you to get all the way from start to finish. Your mileage may vary based on your experience with the topics and how much you read all of the details that we've put in there. It'll time out after 50 minutes. So in order to access the lab, you're going to click the link in the related content box. I think Marco is highlighting it for you, but you'll also see the paperclip again. Make sure you use the same email address for your registration if you're interested in getting the badge. That helps us link you up in the back end. And then finally, if you have problems, please use the chat instead of the Q&A, because that lets us have more of a live conversation with you. We can do things like drop code in there. If you're new to the Instruct platform, you have a progress bar at the top that will tell you how far you've progressed in the challenges and how much time you have remaining. The bar on the right side where the instructions are is toggleable, so you can expand it further out into the screen. You can push it over so that you can see more of the screen. You'll notice there are buttons at the end, or the bottom rather. Don't click exit unless you actually want to quit. That will disrupt the logs and it won't show you having completed. You want to make sure that you click the green check button all the way through and then finish at the end. That's what's going to log you as having done the lab. I think that gets us through the logistics. So again, you don't have to do it right now if you don't want to. It will be available on demand through April 3rd. But if you are planning on doing it, please jump in now. We'll be going off camera, off microphone, so it'll be nice and quiet for you, but keep this running in the background in case we're prepared to answer some questions, etc. So have at it. Hey, Javier, we have a question that I think is worth answering for the group. So I tossed it up in the screen for everyone to see. Are you with us? There you are.
Thanks, Jen.
So this
sorry
looks
about
like
that.
it's demo specific.
Yeah, sorry about that, Priyanka. I don't know exactly what's going on here, but I would suggest in the attendee chat, I've just pasted a command that should just clear out all of the node processes that are going on that might be taking up that port. If that doesn't work, I have another command that is a little bit more aggressive that I'll paste, but that one is perhaps it should still work, but it might. I think it should work. In my testing, I think sometimes it kills the code editor in the instruct lab, but I think the next challenge will restart it anyway, so it's okay. But try that first one, that kill-9 LSOF TCP 4000 command, and that should hopefully get it.
Looks like we got a quick answer. Yes, I did this. I'm only worried if firing those extra commands would alter my progress, and it works, so should be fine, right?
It should be fine, and in general, the instruct is set up so that each section is standalone. So since you're at the very end of that section, you should be fine in the next section. But I'm glad it works. Thank you.
Thanks. Javier, we have a question in the Q&A that I'll go ahead and push over to the main screen so everyone can see it. It's regarding challenge 5. Are you with us?
Yeah, just taking me a moment here. Okay.
Finding all the buttons, right?
Yeah, I may need a little bit more context for this. This appears to be the code so I'll just talk about it until I get more context, but this is the code in the Messenger application. Sorry, incorrect. This is the code in the notifier application that, and actually I can pull it up on my screen, that we will need to replace with new code. So let me share my screen. And I can maybe illustrate what I'm talking about here. So let me back this up here. So online, so this is the index.mjs file in the notifier project. And the first thing we do, this is probably at the very end of the instruct tutorial. The first thing that we do is we provide this line up here, import trace from OpenTelemetry API that gives us access to this object that will let us receive a tracer. And then go down to line 91. The line number should be the same in the instruct. And maybe what I'll do now is I'll go over adding of the code a little bit more slowly than I did in the demo. So the first thing I'm going to do is I'm going to I'm going to add this. I'm going to get a tracer. So there's a get tracer method that's provided by the library that we imported that allows us to pull a tracer that has all the context of the code here. And so this is what we'll use to send a trace. The next thing I'll do is I will use that tracer that I got and call get active span. I'm sorry, that's incorrect. Start active span. This is what happens when I try to do it from memory. Start active span, and I'm going to call it. Notification.send all. This is where we start sending the notifications, and then I'm going to provide it with some metadata. So to do that, you set attributes in an object, and provide another object in there. And for here, I'm just going to set the user ID to the user ID that got passed in by the RabbitMQ message. After that, I'm going to provide the callback. So is where we're actually going to put our code that we're going to measure. So if we just wanted to send one trace, and this is not the final form, we just put that in there. So this is the code that we're measuring here, and that goes in this callback. If you're not familiar with JavaScript, this is going to be a function that the framework will call when it's measuring that span. But we're not going. Let's pull this out for now. So this is the parent span, and we want to do in here we want to do make sure we end our span. So parent span dot end. But we actually want to send a span for every notification that's sent. See here, we're pulling each notification preference that the user specified and sending a message for that. So I want to have a span for each one of those. So I'll just go through the same process again. So I'm going to say tracer start active span. So starting another span inside my other span. You can nest spans like this. And I'm going to call it notification. So I'm keeping the same kind of namespace here. Dot send. So this is sending an individual notification. And just like last time, I'm going to set some attributes on it. And this time I'm going to send notification type. And I'm going to take, I'm sorry, actually, I'm going to send this inside the, this is going to be happening inside the loop here. So loop on the outside here and move this in. So we're inside the loop where we're looking at the notification preferences, and then I'll say pref, because that's one preference, dot address type, and this is just that's the database record. You don't need to know this, but that'll be like SMS or email or something. And then we'll do user ID, pref user ID. So that's the ID of the user who wants to receive that notification. So those are my sort of specific things I want to have in there. And then I'm going to send that callback, and then I'll just call this one span because we're not going to have any more spans below. And then now is where I'm going to put this console log. So this is the actual thing that we're measuring. I'll remove this. So here we have console log, and it's just sending this, it's just printing something out of the console because we're not actually sending it. And then span.end. And that's the whole code that we're going to write. So let's go over it piece by piece again. So that, again, this is down around line 91, and we replace this bracket here that's that is we replace this one, the for let preferences. So what I'm doing here is I'm first going to pull the tracer. I'm going to start a span and name it notification.sendAll. I'm providing some custom attributes here that is helpful for my reading of the trace, data that I want to track in the trace that's not sent by default by OpenTelemetry. And then I'm providing a callback here where it gives us the span so that we can end it later. And inside that callback, I've got now the original code that's the loop where we're looping over all of the different notification preferences that the notifier application found for the user. And then inside that loop, for each iteration, I'm going to start a new span called notification send. Again, I'm providing some stuff that's related to my business logic here so that I can track that in the trace. And then a callback. And then here we just do a console print. You can put whatever you want here. It doesn't actually matter. And then I'm making sure that in each callback, I am ending my span. I'm telling the OpenTelemetry SDK that I'm done with this one. And likewise, I close up the parent span here. So that's what you're supposed to be doing for that piece. And then what you do is you go to the in Instruct, there'll be a tab called Notifier. You can press Control-C if something's running there to stop it. And then you run this command node -- import, and then that tracing.mjs file. So what this does is it loads it into the node process, But you notice we never require this anywhere in our Node application. So it's really the tracing code, the auto instrumentation and setup for OpenTelemetry is really separate from the Node.js application. And then here's the entry point to our Node.js application. So I'll start that up. Hopefully, since I typed out the code, I didn't get any errors. Cool. And then we'll wait for a moment here because, like I said, it produces a lot of file system access trace stuff that can make things a little bit hard to read. And Jen, let me know if we're getting more. Oh, sweet, people are. Oh, Pedro said, "I get it. Thanks. Cool." Well, just in case anyone else had it, and because I want to complete things, I'm going to keep talking until Jen stops me.
We should probably stop. We've only got 5 minutes left, and I just want to make sure in case there's any other questions. We don't want people to end up having a timeout.
Okay. Well, let me just show the trace. Sorry, Jen.
Yeah, sounds
Here's
good.
the trace. So here's what we just set up. I wanted to end the example here. So parent span, child spans here, and those are the ones we just set up. And this warning here, I wanted to mention it in the talk, but this is a setting. It's about clock skew between different things. Clock skew is something if you're doing really minute measurements you would have to worry about, but it's just warning us that we're not accounting for clock skew between different computers in our measurement. But all right, glad that you got unstuck. Thank you.
Okay, we are at the top of the hour, so we're going to go ahead and close out. Dave had to run to another webinar. He's in demand, but Javier, again, thank you so much for your time. I think this was a great session, great lab, great demo. And lots of people have completed already, so good job to everyone who's completed it. Hope you all enjoyed Microservices March. This is the end of the program. We'll follow up with a survey. We'd love to hear what you thought. And again, the content will be available through this platform ending on Monday next week on April 3rd. Thank you.